In this video, we are going to look into frequent pattern group algorithm problem. So let us see a sample data set here where we have 5 transactions T1, T5, T3, T4 and T5. So and for each transaction we'll have a list of items. So now let us compute the frequency of each individual item. Let's take it in order where A you have the frequency of occurrence just here. So A, and then for C you have 1 and 2. So 2, and then for D you have 1. Yes, only 1. And for E you have 1, 2, 3, 4. So the frequency of occurrence of E is 4. And for I we can have only 1 where only 1 occurrences. For K you have 1, 2, 3 and 4. So where you have 4, no 5. So 1, yeah, 2. 1, 2, 3, 4 and 5 here. T4 also have 5. So all transactions have 5 here. So K is 5 and M is 3. We have 1, 2 and 3. So M is 3 and N is 2. So let's see 1 and 2. So N is 2 and O, let us see 1, 2 and 3 and 4. But here the number of occurrences for each transaction only we are computing. So you can see in T1 you have 1 O, in T2 you have 1 O, in T5 you have 2 O. So the occurrence of O in T5 is only 1. So it's for this transaction the O occurrence is once. So for T2 once and then for T1 once. So the occurrences of O in the transaction is only 3. And when you come to U, you have only one U, so it is 1U. And when you come to Y, you have 1, 2, 3, so it is 3. So now all the occurrences of the items has been computed. Now let us take the minimum support to be 3. This a priori also finally helps us to find out the frequent item set. So we need to keep the minimum support count as we have kept for the a priori algorithm also. So we have kept the minimum support count to be 3. So when you discard all this minimum by seeing the minimum support, so A you will discard, C you will discard, D you will discard, and then yes, E will have it, and then I will discard, and then K we will have it, and then M will have it, and then N we will discard, and then O we will have it, and then U you will discard. So finally what all will be there? You will have E, K, M, O and Y. So when we put it in the descending order, the highest order, so K will be 5, E will be 4 and M, O and Y will be 3. So now our list of items is actually set up here. So we have found the list of items which is K is equal to 5, E is equal to 4, M is equal to 3, O is equal to 3 and Y is equal to 3. Now what happens? So you have to eliminate. We have to eliminate all the in our transactions. We have to eliminate the items which do not support the minimum support count. So when you come here, see this is the actual transaction. When you come here, you will have E, you will have K, you will have M, and then N you will not have. So N will not have. So what happens? So E, K, M, O, Y. Again, we will rearrange this transaction in this order. In this order, we will rearrange this transaction. So K, E, M, O, and Y. And when you come here, you have D, E, K, N, O, Y. And again, we will eliminate this N and then this D. So K, E, K, O, Y will be there. Again, if you rearrange according to our list, it will be K, E, O, Y. And you have AEKM where A is not supporting our minimum threshold. So you will have EKM. When you order it, KEM will come. And when you come to the T4 transaction, CKMUY. So here you will not have C because C is having only one minimum support. EKM, when you arrange it to our list order, it will be KEM. Sorry, it will be C will not be there. So K you will have, M you will have, U will not have because U support count is 1. So we'll have K, M and Y. And now if you go to last transaction, CEIKOO. So what will happen? C is not having the minimum support count, and then E is having the minimum support count. I is not having the minimum support count, and then K is having the minimum support count. O is having the minimum support count. So when you consider, it will be K, E, and O. So now this is our final data set that we are going to take it. So now let us insert each and every item. Let us form a FP tree. So now what happens? The root node will be always the null node, and here what happens? Occurrences of each item according to each transaction will be making it as a tree. Now we have K, which is 1, and after K it is forward extending to E, which had occurred once, and then from E it is extending to 1 M, which has 1, and from M it is extending to O, which has 1 time, which had occurred 1 time, and from O the Y has extended, which had occurred 1 time. So for the first transaction, so this is the tree that we have drawn. So now let us insert the next transaction set, which is K, E, O, and Y. So now what happens? We have already K1 here. When you insert this K, now this will become 1 plus 1. So which will become 2 here. Then after K you have E. So E is already 1. So 1 is already there. So another 1 you have, which will become 2. And now from E O, from E O, where E, the O is not extended here. The O is not extended here. So what happens? From E, O is extended, which had occurred once in this branch. And from O you have a Y here. So from O the occurrences of Y is once. And then the next transaction we are coming. Already our K is 2 here. So when you insert this K, it will become 2 plus 1, which will become 3. And then what happens after K? You have E. So E is already 2 here. So 2 plus 1 will be 3. And then from E, let's go for M. Yes, we already have a M here. So 1 plus 1 will become 2 here. And the remaining branch remains as such because we don't have any other to insert. Now the fourth transaction we have KMY. So already what happens? We have K to be 3. So we'll have 3 and 1. So which will be 4 here. And then you have a E after K. But in our transaction we have KM. So we'll extend a new branch where K to M. So M occurrence is 1 here. And then from M you are extending another branch called Y here where the occurrence is 1 here. So when you come to the fifth transaction, you have KEO. So already my K is 4. Now my K will become 1 will get add up here and K will become 5. And after K you have E. So here also you have E. So E is 3 here. So when you add up 1 it will be 4. So from E do you have O? Do you have O here? Yes, you have O here already. So I'm adding this O from E. You already have a O. So now previously it was 1. Now it will become 1 plus 1, 2. So this is the final FP tree that we have drawn for this problem. So when you would have checked K is equal to 5. So let's check. Yes, K is equal to 5. And E is equal to, let's see whether we have any other, E is equal to 4. That is the list we have computed. And the O, M and Y are 3. So when we consider M, you have M here, you have M here. So 2 plus 1 is 3. And when you consider O, which is also 3, so you have 1 O here and 2 O here, which is 3. Yes, and we consider Y, that is also 3, where you have 1Y, 1Y and 1Y. Yes, so our list K is equal to 4, E is equal to K is equal to 5, E is equal to 4, M is equal to 3, O is equal to 3 and Y is equal to 3 is actually fulfilled in this tree. So the perfect FP growth tree has been constructed. Now let us, so this is the final tree. I'm just putting it for references because here after generating the FP tree, we will be generating the conditional pattern base, conditional frequent pattern tree and conditional pattern generated. So first step is conditional pattern base. So how we'll generate this conditional pattern base? So now what I'm going to do is I'm going to take all the nodes from bottom to top. From bottom to top, I'm taking all the nodes. So what happens? You have Y, O, M, E and K. Fine. So now let's see from Y, what are all the paths do I have? So I have K, E, M, okay, K, E, M and O. So this is one path, K, E, M, O, which is reaching to Y. So this is one path, K, E, M, O, 1. This is one path. Now the next path which reaches Y. Yes, there is one path that reaches Y. It starts from K. It starts from K. It starts from K. Yes, it starts from K, E, O, and it reaches Y. So K, E, and O, it reaches Y. So I have put this K, E is to 1. What is this is to 1? This is to 1 is nothing but there is a support count of Y. So when you are going to have this path, so in this path, the support count of Y is 1. So that is why the support count of Y is 1 here. And then when you are having this path for the K, E, comma, O, so K, E, O, where it reaches Y with a support count 1. So the support count here is 1. And you have another path called K, M, Y, where it reaches Y. So K, M, K, comma, M, where the support count is 1. So this is the path. These are all the paths that reaches the Y. Then let's take the item O. So what are all the paths that reaches O? So let us see K, E and M. Okay, so the O is having the support count 1. So the support count is 1 here. K, E and 1. And what are all the other paths, path for O? Yes, you have K, E and O. Okay, K, E and O. So the support count here for O is 2. So K, E and O. K, E and O. And now when you come here for M, so what are all the path? K and E. K and E. So the support count of M is 2. So K, E is to 2. And now what are all the paths? Yes, it is reaching here. So from K to M it is reaching. So K is to 1 because the support count of M is 1. And then when you have the item E, so only one item is coming for the path for E is only one item, which is K. So K is to 4 because the support count of E is 4. So for K, you don't have any nodes to traverse. So the K item conditional pattern base is empty. So now what happens when you find the conditional frequent pattern tree? So what is conditional frequent pattern tree? Now again we are going to, in this combination, conditional pattern base, we are going to check for the combinations of items and those combinations are again supporting the minimum support count. Now let us see, you have K here, you have 1 and for this K you have 1 and for this K you have 1. So for K you have 3 support count which is again satisfying the minimum support count. So K is to 3. Now when you come to E, you have 1 here, you have 1 here. That's all. So E is not having greater than 3, just 2. So I'm discarding, as I told you, I'm discarding E. So now M. So M has 1 and then 1, just 2. So I cannot actually take M is to 2 because it is not satisfying my minimum support count. Now let me take O, which is 1 and here 1. Again it is 2. So again I'm discarding it. So K is to 3 alone is there for conditional frequent pattern tree. Now let's take O. So for this O, you have K, which is support count is 1 and 2 here. So K is equal to 3. And E, if you take, I have 1 here and 2 here. Again, E is 3. So K comma E is to 3. And M, where I have only 1. So M, I cannot take it. So K comma E is to 3. So now when you come here, K is 2 and 1. Yes, I have 3 here. Whereas 2, I have E, I have only 2. So I'm discarding E. So K is to 3. So here K is to 4 I'm taking as such. So this is how I have generated the conditional frequent pattern tree. So now when you come to conditional pattern generator, so what happens, each and every item should be combined with the items, okay, that have been generated. Conditional frequent pattern tree, the items that have generated needs to be combined with its item Y. So now what happens, you have K is to 3. So K comma Y is to 3. So K comma Y is to 3. And now you have K comma E is to 3 where the item is O. So K comma O is to 3 and E comma O is to 3. And also we can make the combination of K comma E comma O, which is again 3. So here now we know that K comma O is 3. Just by combining the support count we can do it. But if we take the combination E comma K comma O, so what will be the support count? So you can see here how many paths you have to reach the O. So when you look into it, you have K, E, M. So you have this path here. So here you don't have M here. There is one path that could reach O. There is one path that could reach O. So KE could reach O. And also you have a KE which could reach O. So the support count of O here is 3. So that is why E comma K comma O is 3. And now when you come to E item, K comma E, K comma E will be 4, where we have already 4. So K comma E will be 4. So these are all the frequent pattern generated. So in a priori, we generate the frequent pattern by scanning the databases multiple times. Each and every time you are scanning the databases. Whereas in FP growth, we are generating in the minimum, in the beginning itself, we are actually discarding the support count and then discarding items using support count, and then we are creating the FP growth tree. So we are only generating the frequent patterns just by scanning this tree. So the time is not consumed more, as well the scanning of databases is also reduced. Hope everybody understood the frequent pattern. We can see another example in our next video. Thank you.